Start recording. So yes, this is going to be another second review, right? Introduction to networking gave you guys roughly a week and a half break to review chapters 1, 2, and 3. Okay, chapter 1 was introduction to TCP/IP networking. Chapter 2 was fundamentals of Ethernet LANs, and chapter 3 was fundamentals of WANs and IP routing. We're going to go through the same format. I'm going to ask you guys the questions. I'm going to pick somebody randomly in the chat to unmute and answer the question. If you need a lifeline, I will tell you who your lifeline is. And of course, with each answer, I will need a breakdown, the who, what, where, why, and how. Reason being, of course, because I need you guys to be able to consult yourself while you're in the exam environment, because that's all you will have when you're taking the exam. All right, last but not least, let's go ahead and get started. So let's go ahead and blow this up. Question 1, chapter 1. Do I know this already? Foundational topics questions. Which of the following protocols are examples of TCP/IP transport layer protocols? Choose 2 answers. Mike Hevia. And your lifeline is Antoine.
Okay. Which of the following protocols are examples of TCP/IP transport layer protocols? Protocols for TCP/IP, the answer would be UDP, so D, and TCP/F.
Why?
Because UDP is a connectionless. It's a connectionless transportation type to where well, I guess it's a connectionless protocol. So I guess there's no need for two-way communication from, I guess, the server. I don't know if I'm explaining that part right, but I know the answers are right. And TCP. Oh, go ahead.
Oh, I didn't say nothing. Go ahead.
Oh, okay. And then TCP is the right answer because it's connection oriented protocol to where two-way traffic and communication is needed.
Okay. So so you explaining that, why does that tell me that they're examples of transport layer protocols?
Because they're transport protocols, like UDP is like one way connectionless communication to where like streaming, like it doesn't need reply, I guess.
Okay.
Okay,
So
that's not the best
it's okay. It's okay. So let's talk through this, right? Remember, guys, keep it simple, right? So the question says, which of the following protocols are examples of TCP/IP transport layer protocols? Which protocols, right? If we're looking at this question, which protocols within the answer list sit at layer 4 within the OSI model? UDP and TCP. Done. Question answered. All it's asking you is which of these protocols are transport layer protocols? Not what it does, just which protocols are transport layer protocols. That makes sense, Markavia?
Yes.
Okay. All right. So remember that for the exam. Let's keep going. Which of the following protocols, question 2, which of the following protocols are examples of TCP/IP data link layer protocols? Choose 2 answers. DeMarco. And your lifeline is Yasin.
Okay. The two data link protocols is A Ethernet and G 802.11.
Why?
For Ethernet, that's the data link protocol. Because it's a connection and it's using that medium. And 802.11 is a wireless protocol, but it also uses a medium to connect that.
Okay. I like where you were going. Same thing with question one, right? What we just went over. Keep it
Mhm.
simple. Where does
Got
Ethernet sit at? Layer two, right?
layer two. Yeah,
That's it. It's a data link protocol.
got you.
Where does 802.11 sit at? Layer two.
Layer two. Yeah.
Data, data link layer protocol, right?
Yep.
That's it. That's your answer and that's your explanation. Keep it
Got.
simple, okay?
Yep. Got you.
All right. All right. Let's keep going. Question three. The process of HTTP asking TCP to send some data and make sure that it is received correctly is an example of what, Gary? And your lifeline is my Kivius.
Thank you, Dave. I'm just gonna read it. Just think about the question before I answer. Just a
Mm-hmm.
second.
Mm-hmm.
And so the answer would be actually between two options, which is same layer and adjacent. I'll actually rule out the TCP/IP model and all of the above answers.
Mm-hmm.
Just C and D are actually ruled out.
Mm-hmm.
Just gonna make sure that I answer right. Same layer interaction is basically when the communication happens between two different hosts.
Mm-hmm.
In the adjacent layer, interaction is basically the communication happens for adjacent layers like layer 2, layer 3, or layer 3 or layer 4. So HTTP is the application layer asking TCP, which basically is asking the layer 4. It is the okay, I would say this is the same layer interaction is the right answer.
Okay. So the process of HTTP asking TCP to send some data and making sure it is received correctly is an example of
Sorry,
same layer interaction.
no, it is the incorrect answer that I gave.
Okay.
To me now, the reason why I said incorrect, I'm only getting confused because HTTP is actually the layer 7, whereas the TCP is the layer 4. We have a two layers in between.
Mm-hmm.
So I'm just being confused, although it is kind of doing a communication as an adjacent layer.
Okay. So let's
Yeah.
break this down.
Okay.
What layer does HTTP live at?
Layer 7.
What layer does TCP live at?
Layer, we just discussed layer 4, which
Okay.
is transport.
All right. So HTTP and TCP don't live at the same layer, do they?
HTTP, no, they don't. Again, yes, in all the upper three layers are the same layers, kind of like as a one stack, right?
Nope, nope, nope. Let's keep it simple and let's rely on the OSI model.
Okay.
HTTP lives at what layer?
Layer 7 application.
TCP lives at what layer?
TCP lives at the transport layer, layer 4.
Okay. So if I'm communicating from one PC to another, that means if, right, if according to this question, if the process of layer 7 is asking layer 4 to send some data, right? I'm not interacting with a protocol at the same layer, am I?
No, it's not the same protocol. It's a,
Okay. So
so
let's break down the answer. What is the word adjacent mean?
um, adjacent would be a layer above or below.
Nope, nope. I didn't say layer. I said what does the word adjacent mean?
I could say in an, how would I say it? Someone sitting right next to me
Absolutely.
would be adjacent to me?
Absolutely.
Yeah.
Okay. That's your answer.
Yes. So it is
Make
the
sense?
adjacent layer. Yes, it does. So
Okay.
option B.
Cool. Cool. All right. I want you guys to remember to break if you are unsure, and it's okay if you're unsure because it's a lot of information. You have to use more tools than one besides memory to break down the question. Okay. All right.
Yes.
Okay. Question 4. The process of TCP on one computer marking a TCP segment has segment 1, and the receiving computer then acknowledging the receipt of TCP segment 1 is an example of what? The answers are either A, data encapsulation, B, same layer interaction, or C, I'm sorry, hold on. Oh, there we go. C, adjacent layer interaction, TCP IP model, or all these answers are correct. This is going to go to Donovan.
Oh wow. Wait, can I see the question again?
Yep, right here.
All the answers.
Let me know when you want me to scroll down to the rest of the answers.
Okay. You go to the other ones. That will fall under like layer 4, I think. The transplant layer. Wait, go to the question again.
Mm-hmm.
I'm gonna say B, same layer, because it's both like under the transplant layer, which is like layer 4. I think. I don't know. I don't get a lifeline. I think it's B. Let me go with B.
Why do you think it's B?
Because isn't that on the transplant layer? Like on the same devices, it's still doing it on the transplant layer.
What's the question, sir?
The process of TCP on one computer is making the TCP segment as segment 1, and the receiving computer then acknowledging the receipt of TCP segment 1 is an example of what? Isn't it like same layer interaction because it's all on the transplant layer on layer
Yep,
4?
absolutely. Just be a
You
little.
drew me like I was wrong. Oh my god!
You know how I do. You're not new to this. I want you guys to be sure, okay? Because on the exam, you won't have me or anybody to confirm your answers, okay?
Okay.
All right, guys. All right. Question 5. The process of a web server adding a TCP header to the contents of a web page, followed by adding an IP header and then adding a data link header and trailer is an example of what? Yasin.
Data encapsulation,
Holy shit. Why?
um, because it's explaining the process of data encapsulation, adding a IP header and then adding a data link header and trailer is the process of encapsulation.
Damn, that's correct. Okay. Question 6. Which of the following terms is used specifically to identify the entity created when encapsulating data inside data link layer headers and trailers?
Can I
Antoine.
help?
No, you can't help. Antoine?
Yeah, you hear me?
Yeah, we got you.
All right, let me read it. Which of the following terms is used specifically to identify entity created, encapsulating data inside data, layer header, and trailers. Okay. That would be D, frame,
Why?
because packet. Okay, so because frame is the unit of data in layer 2.
Perfect. That's amazing. That's a great explanation. Okay, good job. Yasin, great job breaking down question 5. It's quick and easy. I love that. Great job, everyone. Let's go ahead and move to chapter 2, fundamentals of Ethernet LANs. Question 1. Some end user devices connect to a LAN using a cable while others use wireless. Which answer best characterizes which devices use Ethernet to connect to a LAN? Makivia.
Let me read the question.
Mhm.
The answer is A. Only the end user devices that use cables are using Ethernet, because Ethernet is the medium for the LAN connection, I guess.
Amazing breakdown. Okay, that is correct. Question 2. Which of the following Ethernet standards defines gigabit Ethernet over UTP cabling? Yasin.
Oh, sorry. Give me 1 second.
Mhm.
It's going to be 1,000 base T.
Why?
That's the one for it, 1 gig over UTP.
Excellent. Okay. Question 3. Which of the following is true about Ethernet crossover cables for fast Ethernet? Antoine.
Let me read this. Crossover cables. I'll have to review this part.
30 seconds.
This is crossover. I would say B.
Why?
Because I'm trying to remember what the difference between straight cable and crossover cable.
Your lifeline is Geary.
Okay.
You got 60 seconds.
Yes, Dave. Thanks.
Okay, Gary, help me out here.
Okay, so
45 seconds.
the answer would be B to me. The reason is basically pin 1 and 2. They get so 1 actually like transmits so as the 2 on the other end. Pin number 3 receives as well
That's
as
right.
6. And that would be my option that I will pick.
Great breakdown. Amazing.
Thank you.
All right. That is correct. Question 4. Great job, guys.
Thank you, Gary.
Each
No.
answer lists 2 types of devices used in a 100 base T network. If these devices were connected with UTP Ethernet cables, which pairs of devices would require a straight-through cable? Choose 3 answers. DeMarco, your lifeline is Donovan.
Got you. Let me see, each answer lists 2 devices, 2 type of device. Each answer lists 2 type of devices used in a 100 base T network. If these devices were connected to the UTP cable, Ethernet cable, which pair of devices will require straight through cable? So I'm gonna go with PC to switch. PC to switch. Uh
60 seconds.
got you.
You have access to your lifeline.
Got you. So I'm gonna go PC to switch, hub to switch, and wireless access point and switch.
Okay.
So
Why?
B, D, and E. Because
You said B, C, and E?
no, yeah, no, I mean, yeah, B. So it's PC and switch, hub and switch. I mean, that's hub and switch, but PC and switch, wireless access point, and hey, Donovan, you can help me out on the last one.
I think it's A2.
A, PC the
Yeah,
router.
because that'll be
Um,
a
all
straight
right,
through connection. Yeah.
got you. A, B, and
E.
E.
Why?
Because they transmit on the same pins as they transmit on pin 1 and pin 2, and they receive on pin 1 and pin 2.
I agree with that.
Final answer?
Yeah.
Let's read the question again.
All right.
Each answer lists 2 types of devices
Mm-hmm.
used in a 100 base T network. If these devices were connected with UTP Ethernet cables, UTP Ethernet cables,
Right. So it's
with
saying which pairs of devices will require a straight through cable.
straight through a cable.
So which devices will require a straight through cable? So yeah, PC and router, uh, PC and switch, and wireless access point.
UTP Ethernet cables. There's a technology called auto MDIX.
Got you. Auto MDIX. And what auto MDIX does is from what I remember is if you don't it's a technology used if you don't have the correct cable, it
Mhm,
detects it, right?
mhm.
Got you.
It detects what?
It detects whether if you got a straight through cable or crossover cable, right?
Not exactly. What about the pins where
So
auto MDIX comes in?
so well, auto MDIX comes in that if you got so I feel like I know it. I'm gonna just say it. So with MDIX,
Think about question 3, and we talked about the pins.
right? So the data transmit on 1 and 2 and
Mhm.
receive on 3 and 6.
Okay, that's true. What about the devices within our answer slots?
So those devices will transmit on pins 1 and 2 and receive on pins 1 and 2.
So B, C, and E are going to transmit on 1 and 2 and receive on 3 and 6?
No, so that will be only the PC and the wireless access point will receive on 1 and 2 and 3. No, they will receive on 1 and 2, transmit on 1 and 2 and receive on 1 and 2, and the hub and switch will receive on they will transmit on 1 and 2 and receive on 3 and 6.
So that's for B, C, and E, is what you're saying.
No, so I
That
had my bad, my bad. So I did A, B, and E. That's what I did.
so A, B, and E, they
Mhm.
transmit on the same pins.
Not the switch and the router, but the
Okay,
PC and the wireless access point will.
I need three answers though.
So with auto MDIX,
Mm-hmm.
they will transmit on one and they would transmit on 1 and 2 and receive on 3 and 6.
For all of them.
It's kind of confusing me. It's kind of confusing me now because to be honest, I forgot all about auto MDIX with that technology. Um, so all I know for a fact, all of them wouldn't transmit on 3 and 6. Let me see. I mean, on 1 and 2, 3 and 6. 1 and 2.
What
Okay.
does it say right here?
Crossover cable, endpoints transmit.
Nope. Nope.
Oh, you just looking at the name,
I
the
want you to worry
devices.
about the table, the key
Ah,
topic.
so
Which
PCs and NICs,
they transmit on one pins.
1 and 2,
Routers transmit on one pins.
1 and 2,
Okay, what about wireless access points?
1 and 2,
Okay, what about hubs and switches?
3 and 6.
Okay, so if we go back to the question, right, and we're thinking about UTP Ethernet cables, we need to choose three answers. Keep in mind, auto MDIX.
So it will be PC and router,
Hmm.
um, switch pin. The switch will transmit on hubs and switches on 1 and 3, 1 and 2, 3 and 6. So PC and router, wireless
U-
access point.
UTP Ethernet cables.
So that's the unshielded, twisted pair
Mhm.
Ethernet.
Are there three answers in here that transmit data on different pins?
Yeah, it is.
Okay, so what are they?
PC and switch,
Okay,
hub and switch,
nope,
router and hub.
nope. Hub and switch do not transmit on different
Oh
pins.
no, they transmit on the same. My bad, my bad. So it'll be PC and router,
Nope.
PC is
PC and router transmit on the
so
same pins.
let me get an understanding. So if it's saying three answers
Mm-hmm.
and they got two answers for each one,
Mm-hmm.
that's where it's confusing me at.
It shouldn't confuse you. It's asking you each answer lists two types of devices used in a 100 base T network. If these devices were connected with UTP Ethernet cables, UTP Ethernet cables, which pairs of devices would require a straight through cable? Choose three answers. PC and a switch transmit on two different pins, don't they?
Yeah,
Okay, so we can use a straight through cable and rely on auto MDIX.
or PC and switch.
Hold on. Wait a minute. Yeah, for
Gotcha.
PC and switch. PC and router, they transmit on the same pins. We don't have to rely on auto MDIX, do we?
No.
Okay, let's move on. Hub and switch, they transmit on the same pins.
Yep. 1 and 2, 3 and 6.
Okay, so it transmits on 3 and 6, correct?
Uh,
Okay, so we don't have to rely on MDIX. Is that correct?
right. So
Wait a
oh,
minute.
no, my
Nope.
bad.
Wait a minute.
Mm-hmm.
Hub and switch, they transmit on the same pins, right?
Mm-hmm.
Okay, we're not going to use auto MDIX for that, are we?
No.
Okay, so we can cross that out. Okay, router and the hub, they transmit on the same pins?
Yeah. No, they don't.
Okay, wireless access point and a switch, they transmit on the same pins?
No.
Okay, so we're going to have to use auto MDIX, right?
Mm-hmm.
Okay, so your answer is going to be B, D, and E.
Gotcha. So all of those transmit.
Absolutely. So this question, right? It's not going to give you the answer within the question. This is where reading comes in. You have
Gotcha.
to understand what UTP Ethernet cables are. You have to understand, which you were right, what straight through cables are used for, and of course, 100 base T network. Okay.
Gotcha.
All right. All right. Good job. All right. Let's keep
Appreciate
going.
it.
Question 5. Which of the following are advantages of using multimode fiber for an Ethernet link instead of UTP or single mode fiber? Choose two answers. Gary.
Thank you.
Uh-huh.
Okay, my answers are B and D.
Okay. Why?
The reason is we're basically talking about the advantages of using multi-mode fiber for
Mhm.
an Ethernet link instead of UTP or single mode fiber. Again, single mode fiber are expensive
Okay.
to run, and they are looking to use something else other than UTP cable, which is the multi-mode fiber. Multi-mode fibers are cheaper to run,
Mhm.
and they uses the LED-based SFP and SFP plus modules. So that's why I choose the option number D. Option number B, um, to extend the link beyond 100 meters while keeping initial costs as low as possible. So basically, the UTP cables are capable of giving like up to 100 meters mostly.
Mhm.
I know with the newest technology, they can probably go about 300. But again, the thing is, we basically wants to extend the link beyond 100 meters while keeping the initial cost low.
Mhm.
So those are my answers, B and D.
So what's the limit of both of the distance for UTP and single mode as far as in meters?
UTP, I don't remember like all of the categories we have, like category 5, I believe,
Mhm.
is capable of 100-meter.
Okay.
Whereas with the single mode fiber, it can give you in kilometers. Like,
Okay.
because it can give you like in kilometers. I don't know exact kilometers, but yeah.
Okay.
I think
But
it's like 5 kilometers.
what about multimode?
Um, Multimode is more than 100 meters, I believe. I don't recall, I won't lie, but I don't recall 100% how long it can go.
Mhm.
But you can definitely go about more than 100 meters. So
Okay.
those are the cables that get run from, like, I guess, the core switches to the closet switches.
Okay. All right. D and D is correct for question 5. Good job. For
Thank you.
multi-mode fiber, the distance maximum is 400 meters, okay? 300 meters in certain cases, okay? Remember
Thank
that
you.
for the exam.
I will.
All right. Question 6. Which of the following is true about the CSMA CD algorithm? Yasin.
Sorry, just reading the question again.
Mhm.
Honestly, not too sure. I'm just gonna take a guess at B.
Why?
There's 3 answers here. Well, no,
Mhm.
not 3, but 2 of them that refer to collisions. So I assume with the C in it has something to do with collisions. Um, and A just kind of doesn't make as much sense. Uh, um,
Your lifeline is Antoine. I need a breakdown as to why you chose B.
I honestly have no idea.
Reach out to your lifeline.
Uh, any idea, Antoine?
Oh, my fault. I muted myself. Let me see the answers. Hmm. Let me reread the answers again. I go under a lot of conditions. Collisions can happen, but the algorithm defines how the computer should notice a collision and how to recover. Um, I'll say it's B. Um, Correct me if I'm wrong, but from what I remember, the algorithm, the algorithm works. The way the algorithm works, if there is a collision, there is a delay or a timer for each computer on that network. So therefore, it's allowed. Excuse me. Therefore, some type of communication, which is usually half duplex, is allowed to occur. So if a collision happens, then there's like a timer or like some type of delay, which the algorithm does. That way, one computer can transmit, and then the other computer can transmit or send on the network. So that
That's
would be B.
correct. That's correct. Great job. Question 7. Which of the following is true about the Ethernet FCS field? Donovan.
Um, I'm just reading the question. Hold on.
Mhm.
I think I got this question last time. C.
Why?
Because the Ethernet FC S field is in the trailer, not the header. Because it's not 2 bytes, it's 4, and it's not used for encryption. Or error recovery. That's the only thing that's right there.
That is correct. Yeah, great breakdown. Okay, question 8. Which of the following are true about the format of Ethernet addresses? Choose 3 answers. Mike Hevia.
Okay, I'm reading the question.
Mm-hmm.
Um, okay. I think the answers are okay, which of the following are true about the format of Ethernet addresses? Okay, an Ethernet address. So so I would pick B, D, and E.
Okay, why B?
Because the first few bytes of the address is from the manufacturer. So I guess the Ethernet address is, I'm gonna assume, is the MAC address that we're talking about.
You tell me.
Oh my god. Okay. Yeah, it is the MAC address. I'm gonna say it's the MAC address. So the first 3 bytes of an Ethernet address is from the manufacturer. It's like hard coded.
Mm-hmm.
I picked D. The part of the address that holds the manufacturer code is called the MAC, which is true.
Okay.
Okay. Maybe it's not D. And part holds. Oh, okay. Maybe it's okay. Okay, I changed my answer. I think it's B, D, and F. No, no, no. It's B, E. Oh,
60 seconds.
okay, B. It's B. It's B. Um, E and F. That
Okay.
I'm gonna need help on. I don't know.
45 seconds. Your lifeline is Donovan.
Is the lifeline gonna help?
Um, wait, why?
30 seconds.
Okay, let me read the question again. Wait, what answer did you say, friend?
I said B. So each manufacturer puts on a unique OUI code into the first 3 bytes of the address, which is like which is um, pro- provide like hard coded by the manufacturer. So I'm gonna assume that an Ethernet address. I think we're talking about a MAC address, and I'm pretty sure that it is the first 3 bytes of the address of a MAC address.
Yeah, I do think it's B. Um,
15 seconds.
And I think it's. I mean, I thought it was D, but So I said
Isn't
B,
it E?
E, and F. I said B, E, and F. That's the ones that I said.
I'm
5 seconds.
sticking
Oh God.
Okay, time's up. Mike Evie, what's your final answer after talking with your lifeline?
B, E, and
That's
F.
right.
You said B, E, and F.
Yes.
That is incorrect.
Okay. Was it B, D, and E?
That is incorrect. Okay,
That's
let's
crazy.
break this down.
Oh, that's crazy.
Which of the following are true about the format of Ethernet addresses? Choose 3 answers. Answer A. Each manufacturer puts a unique OUI code into the first 2 bytes of the address. OUI stands for organizational unique identifier. Okay, which means, right, this is going to identify the company, right, via the first 3 bytes of a MAC address, not the first 2 bytes. Okay, so we cross out A and we can go ahead and say B is one of the answers that ring true, right? Because it says each manufacturer puts a OUI code into the first 3 bytes of the address. Let's keep going, right? Answer A, each manufacturer puts a unique OUI code into the first half of the address. That's correct. We can go ahead and pick C. Let's look at D.
Oh.
The part of the address that holds the manufacturer's code is called the MAC. That's incorrect. The entire address is the MAC address, not the part that holds the manufacturer's code. So D is incorrect. E, the part of the address that holds the manufacturer's code is called the OUI. That is correct, which means B, C, and E is our answers. Make sense?
Yep.
Oh, F not be it though.
What happened?
Why would you say it's not F too though?
The reason why it's not F, the part of the address that holds the manufacturer's code has no specific name. It does. It's called the OUI.
Oh, I was thinking like name. Other than,
Oh, yeah.
okay.
I see. Got it.
Make sense?
Yep.
Awesome. All right. Which of the following terms describe Ethernet addresses that can be used to send one frame that is delivered to multiple devices on a local area network? Choose 2 answers. Donovan, and your lifeline is Makivia.
Oh my God. Okay. Which are the following terms describe Ethernet addresses that can be used to send one frame to multiple devices? So a broadcast stream, isn't that send it to all devices? Yeah.
60
So
seconds.
broadcast. Okay. C and D. Because multiple a multicast sends it to
30 seconds.
a specific group, and the unicast is like to one. And so yeah, B and C and D.
15 seconds. You can consult with your lifeline.
Mikey, yeah.
Oh, yeah, I agree. Yeah, it's C and D.
5 seconds.
Yep, I agree.
Yeah, broadcast and multicast.
All right, time's up. That's your final answer?
Yeah,
Okay. Why did you choose those 2?
because unicast is like to one communication, and like the burnt end, doesn't that use like the Mac and the Nick or something like that? Like not to like it's like a group or something, I think. And that's the only thing that broadcast sends that to multiple devices and multicast too. So that's why I chose that.
Good job. Great breakdown. Okay. Awesome job, guys. All right, let's go to chapter 3. All right, chapter 3, last one. Which of the following terms is not commonly used to describe a serial link? Yasin. You're muted.
Sorry. E-line?
60 seconds.
Final answer?
45 seconds.
I
Lifeline is
don't.
Gary. 30 seconds
Is that
left.
Gary?
Yeah, I think E-line would just be not commonly used as described as a serial link, whereas
No.
private line, point-to-point, and least all,
All are pretty used.
yes, and inter-exchange too when we talk in the ISP world, I believe.
15 seconds.
That's my final.
Final as well.
5 seconds. Okay. Yasin, your final answer?
B.
Why did you choose D?
Just never really heard the other, or not. Well, I don't really hear Elon being used
E-line being used for what?
to describe a serial link.
Good stuff. That is correct. Okay. Question 2. Two routers, R1 and R2, connect using an Ethernet WAN service. The service provides point-to-point service between these two routers only, has a layer 2 Ethernet service. Which of the following are the most likely to be true about this wide area network? Choose two answers. Antoine. Your lifeline is DeMarco. You're muted if you're talking.
Sorry about that. Which of the following terms is not commonly used to describe a serial link?
Nope. Question 2.
Oh, sorry. Read it to using Ethernet WAN service. The service provides point-to-point service between these two routers only as a layer 2 Ethernet service.
60 seconds.
I'm going to link
45 seconds.
A and
30 seconds. 15 seconds. 5.
I want to use my lifeline.
Okay. DeMarco.
Yeah, I'm gonna go with A and I'm gonna go with B because it's just describing a point-to-point connection between two routers.
Final answer.
Yeah, let me look at it again, but I believe I'm gonna go with A and B because it's not asking about forwarding any data link frames, so I'm gonna eliminate C and D. So yeah, I'm gonna go with A and B.
Okay. Final answer. A and B.
Yeah.
Antoine. A and B.
Yes.
Okay. That is incorrect. Okay. The question, two routers, one and R2, connect using an Ethernet WAN service. The service provides point-to-point service between these two routers only, has a layer 2 Ethernet service. Which of the following are the most likely to be true about this wide area network? Choose two answers. Let's examine answer 1. R1 will connect to a physical Ethernet link with the other end of the cable connected to R2. That is incorrect. Okay. All right. Your equipment at one site will connect to the ISP equipment. Okay.
That's
Mm-hmm.
right.
The goal of
That's
the
right.
ISP is the goal of the ISP is to extend your physical layer. Okay, so you won't connect directly to your other router. The
Gotcha.
goal of the layer 2 WAN Ethernet service is to extend your layer 1. Okay,
Right.
so it's not A. Let's look at B. R1 will connect to a physical Ethernet link with the other end of the cable connected to a device at the WAN service provider point of
One
presence.
presence.
That
Yes.
is correct. Okay.
Mm-hmm.
Let's
All
see.
right. So let's look and see. R1 will forward data link data link frames to R2 using an HDLC header and trailer. We are talking about the Ethernet WAN service. It does not use HDLC. It uses 802.3 standards, which means it's going to use a header and trailer. HDLC does not use a header and trailer. Okay. So
Gotcha.
Okay.
it cannot be C. Let's talk about D. R1 will forward data link frames to R2 using an Ethernet header and trailer. Since, of course, we're talking about an Ethernet WAN service and it's providing a layer 2 Ethernet service, the answer is B and D.
Gotcha.
It makes sense?
Yeah.
Makes sense.
Yeah. It just confused me a little bit because it was just speaking on point-to-point connections.
It's all good. It's all good.
Gotcha.
It's meant to cross you up a little bit. All right. Question 3. Imagine a network in which PC1 connects to the same Ethernet LAN as router 1. PC2 connects to the same local area network as router 2. And the two routers connect to each other with a PPP serial link. When PC1 sends data to PC2 and router 1 removes the Ethernet header and trailer, which of the following is true? Gary.
Thank you, Dave.
And your lifeline is Yasin.
Just thinking about the question before I answer.
Okay. $50. 45 seconds. 30 seconds. 15 seconds.
Answer C and D.
5 seconds. Time's up. What's your final answer?
C and D.
Okay. That is incorrect. It didn't ask you for multiple answers. It asked you for one.
So sorry.
Okay.
Okay.
All
Let
right.
me just think.
Okay.
Okay,
You get an
you can
addition.
go ahead. I want to remove one of them and see if
Okay.
I'm still right.
Which one do you want to remove?
I would like to remove C,
Okay. So what's your answer?
D.
Okay. Final
Router
answer?
one. Yes.
Okay. That is incorrect.
Okay.
Okay. All right. Let's break this down.
Yes.
Router 1 does not use the removed header and trailer again. That is correct.
Router
Okay.
1 receives the packet from the PC, which has the MAC address.
Mhm.
I know the MAC addresses gets removed and rebuilt at every single hop
Mhm.
because basically, no, oh, maybe.
Yep. You're right.
Okay, yeah. So
So
MAC
hold on.
address.
So every layer 3 boundary,
Yes,
the layer 2 instance for a frame will change every time it traverses it. Okay. So
that's right.
that means B, C, and D is incorrect. And A is the only one that's true. Okay.
Okay.
Remember,
Use
guys.
the removed Ethernet. Okay.
Remember, guys, right? The layer 2 header and trailer will always be removed whenever it's crossing a layer 3 boundary. Okay. All right. Let's move forward. Good job. Question 4. Which of the following does a router normally use when making a decision about routing TCP/IP packets? Yasin, and your lifeline is Makivia.
Um, since this is talking specifically about um a router making forwarding decisions, I'm gonna go with destination IP address.
45 seconds. You can
It
consult your
also,
lifeline.
yeah, it also mentions
30 seconds.
I don't know,
It's right. He right.
15 seconds.
wouldn't even say the Mac or
5 seconds. Time's up. What's your final answer?
uh the destination IP address.
Why?
Because to route it, it needs a I guess like a destination to send it to.
That's correct. All right. Question 5. Which of the following are true about a local area network connected TCP/IP host and its IP routing forwarding choices? Donovan, and your lifeline is Antoine.
Okay.
60 seconds.
They think it.
45 seconds.
If they see
You can
the
consult your
host sends the
lifeline.
packet to the default gateway, the destination IP address is different from the subnet in the host
30 seconds.
because the host always sends the packets to the default gateway. The timer, like, I can't think what else. See, it's one all right.
Hey, it's A.
15
Oh,
seconds.
It's
okay, hey,
A. It's A.
5 seconds.
hey,
Yeah, it's A because
Time,
it's gonna
time's
send
up.
you. It's A because in order to route any type of information, it goes to that default gateway, and the default gateway makes that routing decision to go to this destination.
I don't know why I didn't think like that. Oh my god, it is a
So is A you guys' final answer?
yeah.
That is incorrect. Okay.
It sounds like the way he explained it.
Okay. Let's break it down. Which of the following are true about a local area network connected TCP/IP host and its IP routing forwarding choices?
LAN.
Again, a
Okay, LAN.
local area network connected TCP/IP host and its IP routing forwarding choices. Okay. A host, it means either a PC or a printer or a switch that has IP address or a router that has an IP address, as long as it's on a local area network.
Right.
How does it make its forwarding decisions? The host always sends packets to its default gateway. What if it's sending packets to a destination that's within its local area network? It doesn't need to send it to its gateway, does it?
No, only if
Oh,
it's outside this network.
there we go. So that means A is incorrect. If we look at B, the host never sends packets to its default gateway. That's incorrect, isn't it?
Does.
That
Yeah.
is incorrect. Yeah.
Okay, so if we look at C, the host sends packets to its default gateway if the destination IP address is in a different subnet than the host.
I
Well,
think
that's
that's the answer
that's
though,
that's
true.
right?
that's true, isn't it?
Yeah, it's true.
Yeah.
Let's look at D. The host sends packets to its default gateway if the destination IP address is in the same subnet as the host. That's incorrect, isn't it?
Incorrect. Yes.
Yeah.
Okay, so what is the right answer?
C.
Okay, see.
That is correct. Great job. Okay, question 6. Which of the following are functions of a routing protocol? Choose 2 answers. DeMarco, your lifeline is Yasin.
Got you. Which of the following functions are which of the following are functions of a routing protocol? Advertising on routes to its neighboring routers, learning routes to directly connected subnets, learning routes as advertised to the router by its neighbors.
45 seconds.
All right, so I'm gonna go with A and I'm gonna go with
30 seconds.
C.
One of the answers is definitely D.
15 seconds.
All right, so I'll go with A and D.
5 seconds. Time's up. What's your final answer?
So A and D.
A and D?
Yeah.
Why?
So whenever you got IP addresses and it's going through that default gateway, the router automatically learns that IP and sends it to the routing table to the neighboring routers to the routing table.
So a router automatically does that without a routing protocol?
So I mean, no, it needs a routing protocol.
Okay.
Whether it be like RIP or OSP.
Mhm.
Um, so it is it. Let me see.
The question is asking, which of the following are functions of a routing protocol? At a fundamental level. It's not asking for specifics. It's asking for what are the functions of a routing protocol at a fundamental level.
So I'm gonna go with D and I'm gonna go with B.
So B and D,
Yeah,
is that your final answer?
yeah.
That is incorrect.
Ah,
Okay, let's walk through the answers.
okay.
So the question asks, which of the following are functions of a routing protocol? Choose 2 answers. Okay,
hmm
if we look at A, advertise known routes to neighboring routers. Well, that's what a routing protocol is supposed to do, right? Is advertise its known routes to its neighbors, correct?
Yeah.
Right.
Okay, all right. So A is correct. It's one of the foundational
And
functions
I
of a
said
routing
that at
protocol.
first. That's crazy.
Okay, let's look at B. Learning routes to directly connected subnets. Well, why would it learn routes to its directly connected subnets? when those automatically get installed whenever you configure an IP address on that device. So
Right.
that's incorrect, isn't it?
Mm-hmm.
Okay, so we can cross out B. Let's look at C. Learning Routes has advertised to the router by neighboring routers. Well, that's part of what a routing protocol should do, correct?
Mm-hmm.
Okay, all right, that's correct. Well, if we look at D, forwarding IP packets based on the packet's destination IP address. Is that a function of routing protocols or is that a function of IP routing?
That's IP
IP what?
routing.
Oops.
Okay. All right. So what are our answers?
A and C.
There we go. All right. Question 7. A company implements a TCP/IP network with PC1 sitting on an Ethernet local area network. Which of the following protocols are features? Which of the protocols and features, I apologize, requires PC1 to learn information from some other server device? Yasin, your lifeline is Geary. 60 seconds.
Okay. Ethernet LAN, virtual, there's some other devices. Some local area network. Don't want CTS. I'm gonna go with ARP.
30 seconds. Your lifeline is Geary.
Gary, what you think?
Definitely ARP is the address resolution protocol, as well as C, which is the domain name system. Option B is just the tool we basically use.
15
So
seconds.
for ping to work, you need to have an ARP address. Like you need to have an ARP.
It's only asking for one answer, so
5 seconds.
we'll do ARP.
Oh yeah, sorry. I think I would go with the C.
Time's up.
Mm,
What's your final answer?
Final answer is gonna be A, ARP.
Why?
Pretty sure ARP operates on layer 2.
Can I give my why?
Nope. It's Yasin's question. So, Yasin, you said ARP.
Yes.
Final answer?
Yes.
That is incorrect. Let's read the question again. A company implements a TCP/IP network with PC1 sitting on an Ethernet local area network. Which of the following protocols and features, okay, requires PC1 to learn information from some other server device? If I'm using ARP, and am I reaching out to a ARP server?
No.
Okay, so A is incorrect. If I'm using ping and I'm reaching out to a ping server,
No.
okay, so B is incorrect. If I'm using domain name system, aka DNS, and am I reaching out to a DNS server?
Yeah.
Okay. Can I get information from this DNS server?
Yeah.
Can I learn information from this DNS server?
Believe so.
Okay. All right. So that's a potential correct answer, right?
Yeah.
Okay, let's look at D. None of the answers are correct. Meaning none of these answers are another server device.
Gotcha. Okay.
So what's your final answer?
Yeah, DNS then.
Okay, that is correct. All right, guys. So great session. Feedback from me. You guys need to go back and read chapters 1, 2, and 3 thoroughly. Actually slow down and read it and actually do the of course the do I know this already questions before you read, after you read, and look over at the end of the chapter the review topics. What's a review? Okay, make sense?
Yep.
Yep.
All right,
Yeah.
guys. I will
Yep.
see you Sunday, and we will go ahead and start part 2, implementing Ethernet LANs.
All right.
Already.
Thank
All
you,
right,
guys.
guys.
Bye, guys.
Bye.
Thank you.